Hi, I'm Charles Dillard with Amphenol Broadband Solutions. Welcome to our Fiber 201 training series. In this training, we will cover fiber to the home troubleshooting. As you go through this training, the chat will be open. So if you have any questions, feel free to put those in the questions section. And at the end of this training, we will address all of those questions. So let's get started. Fiber optic safety is critical for every technician working in the field. Always remember that fiber systems are using invisible laser lights that can cause serious and permanent eye damage. Never look directly into a fiber connector, bulkhead, or active port, even if the system appears to be off. Treat every fiber as if an active laser signal is present. Inspecting or testing, use proper optical safety tools such as an inspection scopes with built-in safety filters. In addition, never touch the bare end of fibers, as the glass fragments are extremely small, sharp, and can easily penetrate your skin, causing injury or infection. Fiber shards should always be disposed of in a dedicated fiber waste container, never in open trash. Always wear safety glasses when cleaving or splicing fiber to protect your eyes from glass splinters and stripped coatings. Keep your work area clean and organized. Never eat, drink, or touch your face while working with fiber. Microscopic shards and alcohol-based cleaning fluids can be hazardous if ingested. By maintaining these habits, such as treating lasers as active, wearing protective eyewear, handling fibers carefully, and keeping food and drink away, you create a safe, professional environment for yourself and your coworkers while maintaining the integrity of the fiber network. Inspecting fiber connection before making any connection is one of the most critical practices in fiber to the home maintenance and installation. A single dirty or damaged connector can compromise an entire optical link, even in an otherwise perfect network. Understanding why inspection is essential helps technicians prevent unnecessary outages, protect the equipment, and maintains network reliability. Fiber connector must have clean, smooth, and perfectly aligned end faces for light to transmit efficiently. Any dust, oil, or scratch on the connector causes insertion loss, which is a drop in optical power, and return loss, which is light reflecting back into the source. Even microscopic debris invisible to the naked eye can block or scatter the light path, creating intermittent service or a complete loss of signal. When light reflects at a dirty or damaged surface, it not only reduces the power reaching the ONT, but can also cause back reflection that interferes with the laser transmitter inside the OLT or optical transceiver, degrading the network performance across the pond. Modern optical systems use high-powered laser sources. If a contaminated connector reflects light back into the laser, it can cause overheating or permanent damage to costly optics. This is why inspecting and cleaning connectors before plugging them into the OLT, EDFA, or test equipment is not optional. It is mandatory for equipment protection. Most fiber to the home outages are caused not by broken fibers, but by contamination. Studies show that roughly 80% of fiber-related issues traces back to dirty connectors. When technicians skip inspection, they often spend hours chasing what appears to be a network fault when it's simply a dirty interface. A quick inspection and cleaning step before connecting can save hours of wasted troubleshooting and unnecessary dispatches. Instruments like OTDRs, optical power meters, and OLTs directly affects accuracy. A dirty launch cable or test jumper can introduce false events, high loss readings, or reflection that mimic real faults. By inspecting and cleaning all reference jumpers and adapters before testing, technicians ensure valid baseline readings and trustworthy data for certification or troubleshooting. Every time a dirty connector is inserted into an adapter, it can scratch or contaminate the mating surface of the opposite side. Over time, this degrades the entire connection, causing permanent loss and costly replacement. Preventive inspection protects both the connector ferrule and the adapter sleeve, extending the life of the network components and minimizing repeat service calls. Tools and test equipment that might be used when troubleshooting fiber to the home issues includes a light meter, an OTDR, a fiber scope, and a visual fault locator. In a fiber to the home system, understanding the expected signal level at each point in the network is essential for accurate troubleshooting and performance verification. The network begins at the OLT, located in the head-end or central office, which transmit the optical signal downstream to multiple customers. The OLT typically transmit at a power level between +1 and +5 dBm, and it receives return signals from the ONT in the range of -8 to -27 dBm. If the transmit power is below the range, it often indicates a weak or failing laser or dirty OLT port. These values can be verified either through the OLT's built-in diagnostic or by using an optical power meter at the OLT port. From the OLT, the signal travels through the feeder fiber, which is the main optical trunk connecting the head-end to the splitter cabinet. The feeder may span anywhere from 2 to 20 kilometers and should experience a loss of roughly 0.3 to 0.4 dBs per kilometer, plus an additional 0.1 to 0.2 dB for each connector or splice. After accounting for this distance loss, the expected signal at the splitter input should still measure between 0 and +3 dBm. If readings are significantly lower, technicians should inspect for crushed cable, tight bends, or a poor splice within the feeder path. The next major test point is at the splitter cabinet, where the optical signal is divided among multiple customers. The amount of power reduction here depends on the splitter ratio. For example, a 1x32 splitter has about 16 to 17 dB of loss. Therefore, if the splitter input is around 0 dBm, each output port should measure between -16 and -17 dBm. If all outputs show equally lost or no power, the problem is likely at the splitter input or inside the splitter itself. If one or two outputs are low, those specific output connectors, pigtails, or distribution fibers may be contaminated or damaged. After the splitter location, the signal travels through the distribution fibers, which deliver the divided signal from the splitter cabinet to the local service terminals. These runs are typically between 500 meters to 2 kilometers long, with an acceptable loss of about 1.5 dB or less. The expected optical power at the input of the MST or the multi-port service terminal or distribution terminal should therefore fall between -15 to -25 dBm. If readings are significantly lower, it usually indicates excessive attenuation caused by light bends, poor splices, or connector contaminations. At the drop terminal or MST, the signal is routed into the customer's drop fiber. The optical power entering the MST should still be between -15 and -25 dBm, and very little additional loss should occur within the terminal itself, typically less than 0.5 dB. If there is no power at one of the ports, it could be due to a disconnected or dirty hardened connector, a broken pigtail, or water ingress in the enclosure. The drop cable carries the signal from the MST to the customer's premises and is often between 30 and 200 meters long. The total expected loss in the drop is minimal, typically no more than 0.5 to 1 dB. By the time the optical signal reaches the ONT, or the optical network terminal inside the customer's home, the received power should be between -15 and -28 dBm. The ONT itself transmits light back towards the OLT at the power level between 0.5 and +5 dBm, depending on the model. If the ONT received power is below these levels, it indicates either excessive loss in the drop or contamination at the final connector. For the most part, fiber troubleshooting follows a systematic path that moves from the customer back towards the head end. Technicians typically start by checking the ONT's power and cleaning connectors, then measure received optical power. If no light is detected, they move upstream to the drop terminal or pedestal, testing the drop cable for continuity and reflection. If signal loss persists, testing proceeds to the splitter cabinet to verify the feeder input and output levels. Only after verifying that the distribution and drop sections are functioning properly should the head-end be tested, since issues there usually affect multiple customers at once. In the head-end itself, dirty patch cords and faulty jumpers at the OLT panel are common sources of reflection alarms or low receive power. Occasionally, an incorrect or unplugged jumper leads to total service loss on the PON. Defective or weakened SFP modules inside of the OLT can produce low transmit power, causing downstream signal degradation across all customers. High return loss from dirty connectors or poorly polished jumpers can further degrade performance and increase bit errors within the network. Not all fiber to the home issues are optical. Logical and configuration errors at the OLT or network management level can mimic physical faults. Common examples include incorrect ONT registration due to a mismatched serial number, wrong service profile, or VLAN misconfiguration. Firmware mismatches between the OLT and the ONT versions may prevent successful authentication, even though optical power levels are normal. In other cases, the optical layer performs perfectly, but the service fails because of IP addressing conflicts or authentication timeouts in the back-end system. These problems often appear as no internet complaints, even when the optical levels and the PON LEDs are healthy. Coordination between the field technician and the network operations center is essential to confirm whether an outage is optical or logical in nature. Even when fibers are physically intact, improper optical power levels can cause communication errors. Low power levels typically result from excessive loss across many splices, dirty connectors, or long runs beyond design limits. Conversely, short-distance connection can produce power levels that are too high, potentially overloading the ONT if an attenuator isn't installed. Excessive optical return loss occurs when connectors are mismatched or dirty, leading to unwanted back reflection that disturb transmission. Unbalanced power levels across the splitter outputs are another issue. When one output leg shows much higher loss than the other, customers on that leg experience degraded services. Regular optical power measurements and comparison against design values are key for detecting these imbalances. Feeder fiber and head-end issues tend to affect many customers simultaneously since they occur before the splitter. The most seriously is a feeder fiber cut, typically caused by construction, excavation, boring, or rodent damage. When this happens, an entire PON goes dark. The optical splitter cabinet, which divides a single feeder into many outputs, is another key area for troubleshooting, especially when multiple customers are affected. Splitter-related issues usually come down to contamination or physical damage. A dirty or cracked splitter pigtail can cause signal loss on several drops fed from that port. Occasionally, a splitter module fails internally due to a damaged fusion point or fiber break inside of that device. Using the wrong splitter ratio, for example, installing a 1x16 instead of a 1x32, can cause and create unexpected optical power levels. Loose adapters in these cabinets may cause intermittent power readings, and improperly routed patch cords that exceed minimum bin radius can introduce hidden losses. Proper labeling, strain relief, and inspection at this location prevents many large-scale outages. Moving upstream, the distribution fibers that link the splitter cabinet to multiple customers' terminals can also develop faults that affect several subscribers at once. Cracked splice trays or loose splice protectors are common causes of increased insertion loss. If a closure is improperly sealed, moisture and dirt can contaminate the splices and connectors. Microbending or excessive tension can slowly degrade signal levels. In aerial networks, fiber strain from wind or pole movement can cause small bends visible on OTDR traces as gradual slope changes. Mislabeled fibers or ports are another frequent issue during restoration work. Technicians may connect the wrong leg of the distribution bundle, leading to a service on the wrong address. When troubleshooting a single customer fiber to the home issue, always start at the customer premises and work backwards. Begin with simple checks like power and cleaning before moving into more advanced optical tests. Inspect every connector, clean every interface, and measure light at each step. The majority of single customer problems stem from dirty connectors, bent fibers, or damaged drops, not from OLT or splitter failures. By following a consistent, layered troubleshooting process, you can isolate and repair customers' outages quickly while keeping the rest of the network intact. Most fiber-to-the-home service calls begin at the customer's home, where the problem is often simple but easily overlooked. Dirty connectors are by far the most common issue. Dust, oil, or fingerprints on the end face of a fiber connector at the ONT can cause high reflection and severe signal loss. Loose or cross-threaded connectors also lead to poor optical coupling, particularly if an angled connector is mistakenly mated with a flat one. Technicians also find tight bends behind furniture, routers, and wall plates. Sharp fiber band reduces optical power and causes intermittent loss of signal alarms on the ONT. In some cases, these drop cable is physically damaged by staples or pets. Other common causes include ONTs that have lost power due to unplugged power supplies, bad adapters, or failed battery backup units. The customer drop, the short fiber between the terminal and the home, is the most vulnerable part of the fiber-to-the-home network. Broken or kinked drops are common, especially after yard work, construction, or harsh weather. Often these drops were installed too tightly through a conduit, creating stress points that later fail. In many cases, technicians find drops that were never properly terminated or connected to the wrong port of the MST or pedestal. Outdoor connectors, particularly hardened types, can collect dirt, dust, or moisture if the sealing gasket isn't properly seated. Water intrusion in the drop or MST may freeze and expand, increasing optical attenuation. And finally, unsecured or loosely connected fibers can vibrate and wind or shift over time, causing intermittent connection loss. When troubleshooting a single customer issue at the MST, the goal is to isolate whether the problem is with the customer's drop or the MST port itself. The MST is a shared connection point, so a single customer outage usually means the issue is localized to one port or one connector. Begin by verifying that the other customers serviced by the same MST still have light and service. If they do, the feeder and distribution fibers are good. Next, inspect and clean the customer MST port and drop connector, as contamination is the most common cause of signal loss. Use a visual fault locator or an optical power meter to check for light at the MST port. If light is present, the fault is likely in the drop cable or inside the customer's home. If there is no light at the port, the connector may be cracked, the port misseated, or the splice damaged. Always clean, retest, and document your power readings before replacing components. In most cases, a dirty, damaged, or improperly connected port is the root cause of single customer outage at the MST. Multi-customer fiber-to-the-home issues almost always originate in shared network segments, such as the feeder fiber, splitter cabinet, or distribution fiber. To troubleshoot efficiently, start by determining how many customers are affected. Then verify optical power flow step by step from the OLT to the splitter and through the distribution network. Always inspect and clean connectors first. Measure light at every junction and use an OTDR when necessary to find hidden breaks or excessive losses. By following these structured steps, technicians can quickly isolate whether the outage is caused by a splitter failure, feeder cut, or a shared connection problem, restoring service to multiple customers with minimum downtime. When troubleshooting an optical line terminal, or OLT, always begin with basic physical and optical checks before moving to configuration or software. Step 1. Check all fiber jumpers and OLT port connectors for dirt or damage. Clean both ends using proper fiber cleaning tools before reconnecting. A dirty port can shut down an entire PON. Step 2. Measure transmit level and receive power level at the OLT's PON port using a power meter or check internal readings through the OLT's interface. Transmit levels should be between +1 and +5 dBm. Receive levels should be between -27 and -8 dBm. If transmit level is low or absent, replace or reseat the transceiver. If receive level is low, check the splitter or feeder for high loss or breaks. Step 3. Use the OLT's management system or CLI to verify port health. Look for alarms such as loss of signal, authentication failures, or loss of frames. These indicate optical or registration problems. Step 4. Confirm uplink and configuration. If the optics are good but customers still have no service, check uplink ports, VLAN assignments, and ONT registrations. Ensure ONTs are properly authenticated with correct serial numbers. When several customers on the same PON experience service degradation or loss, the splitter is one of the first shared points to check. Troubleshooting begins with a careful inspection of the splitter's physical connections and verification of light levels at both of the inputs and outputs. To troubleshoot an optical splitter, inspect and clean all connectors, input and output. Measure input power to confirm light from the OLT. Check output ports for even distribution and expected loss. Use an OTDR if loss or reflection persists. Replace the splitter if readings are abnormal or light is missing across all ports. In most cases, fiber-to-the-home problems follow predictable patterns. Single customer outages tend to result from dirty connectors, bent drops, or damaged patch cords. Partial PON outages often point to splitter or distribution fiber issues, while complete PON loss usually trace back to feeder fiber cuts or head-end faults. Across all levels, contamination remains the #1 cause. Roughly 80% of service interruptions are due to dirty connectors. The best troubleshooting strategy begins with inspection and cleaning, followed by systematic optical tests using tools such as VFL, power meters, OTDRs, and OLTSs. That concludes this training on fiber-to-the-home troubleshooting. You should now have a better understanding of how to safely and efficiently troubleshoot fiber-to-the-home outages, which in turn will help you to maintain an optical performance within your network. I see that some questions come in, so I'm gonna walk over to my computer and we'll begin answering those questions shortly. Okay, I see that we do have a couple of questions that came in. First one is from John. Is troubleshooting for fiber to the home different than traditional fiber network troubleshooting? Yes and no. Fiber is fiber. The difference would be the architecture, but the equipment that you would use to troubleshoot fiber, would still be the same equipment. So your OTDR, your power meters, your VFL, etc. Probably the biggest difference when it comes to like troubleshooting fiber to the home versus traditional fiber. So if we start with like traditional fiber, so you would have your head end, you would have fiber that may feed a fiber node, and then off of that node you would have your RF, your coax network feeding all your taps. So in that instance, you're dealing with a point to point. But with fiber to the home, you're dealing with a point to multi-point, and those multi-points would be the ONTs or ONUs, depending on if you're doing RFOG or EPON at the subscriber's home. So you have all these multi points out in the network that is still leveraging fiber. So in a sense, that's really what's different when it comes to the difference in troubleshooting a traditional fiber versus fiber to the home. Just because you're dealing with, one was a point to point, now you're dealing with a point to multi-point. The other probably, I guess, I wouldn't say difference, but I would say something just to be mindful of is that like with a traditional, point-to-point network, typically there may be, dark fibers associated with it or spare fibers, for like, future growth. So with that, you have the ability to, just hook up an OTDR and run tests. Whereas, with fiber to the home, you want to be mindful that you can't just plug into that point to multi-point because traditionally there's not any, dark fibers when it comes to fiber to the home. So, you want to think that it's always active. There typically won't be like spare fibers. And that's the beauty of fiber to the home architecture is that you can leverage that one fiber feed and then, split it off with an optical splitter to feed, multiple ONTs out at subscribers' home. So those two things would probably be, just top of mind, some of the difference with troubleshooting fiber to the home versus traditional fiber networks. But great question. Victor, what was the hardest thing for you to grasp when it came to troubleshooting fiber networks? Well, for me, if I talk about like fiber to the home, by the time it launched, when I was, working for one of the MSOs, I had already transitioned to the training organization. So my role was more of building the training content for the technicians for fiber to the home. So part of my role was to help the trainers to establish the labs that they would need for the training, and then partner with the engineering group to make sure that not only is the content that we're training does it mirror what engineering is saying that it should be as far as what the levels should be and how you should, connect the devices to the fiber to the home network. So I didn't really have to, in my time in the field, troubleshoot fiber to the home networks. But I guess to answer your question, just fiber troubleshooting in general, probably the hardest thing for me to grasp, and it wasn't even just in fiber, this was in RF as well, is that understanding that when you're dealing with a network, understanding how important margins are. So if you attended I think it was in the fiber math training for this Fiber 201 series, we talked about when you're setting up a fiber to the home network, you're going to have your OLT in the head end or hub site, and then you're going to have all your devices at the customer house, and then you're going to have everything in between on that passive optical network. Well, you have to have your optical link budget. So if a OLT is going to transmit out at anywhere from +2 to +7 in the head end, and then, the receive level for those ONTs at the subscriber's home has a received level, between, -15 to -28 or whatever the metric is, then the amount of attenuation between that you can afford to lose is designed in that link loss budget. And, but you also have to include some margin with it, so when there's changes in the network, whether it's due to temperature change, or if there's a situation where you have to add, additional splices because something got damaged or cut or whatever the situation, then you want to make sure that you have enough room for error so that those devices will stay online. So for me, when it came to like troubleshooting in general, whether it's fiber to the home or RF, was understanding that margins are very important because what could be working today may not be working tomorrow. And part of that is making sure that whatever your company's spec for downstream and upstream, typically there's a window. So you want to make sure that you're staying away from the edge of those windows as much as possible to account for any changes in the network, whether it's from damages, aging of the fiber, um, or temperature changes as well. So, but once I understood that, I treated troubleshooting differently, and I think what that did was help me to be better at looking for potential problems that could occur that could affect the customers down the line. Probably the other thing was, if I were to be honest, is when it comes to like understanding my equipment better. Even like with an OTDR, understanding like even with something as simple as pulse width. Depending on if you're doing a short one or a long one, whether your distance that you're trying to test for is a short, medium, or long run, understanding, how important it is to make sure you have the right settings for your equipment. Because if you do set it up for a long pulse width, over like 300 milliseconds or nanoseconds, it can mask problems that you typically would see if you were to do it with a shorter pulse width. So, and that's just because of like with fiber to the home, you have fiber, but they're different length. So, for example, your drop length may be only a few meters, but the distance from like the MST back to the optical splitter, or from the optical splitter back to the OLT, you have these different distances. So you just want to make sure you're using the correct pulse width, depending on what portion of that fiber to the home network you're troubleshooting. So if you're troubleshooting like a standard fiber to the home, it's a point to point. So, you're basically probably using a long, pulse width to shoot for that because you have more distance to cover. So, so me understanding that was, once I got better at that, that made, troubleshooting fiber a lot easier for me. Carrie asks, will there be a Fiber 301 series? Short answer is yes. It'll be a little different than the 101 and the 201. Whereas with our Fiber 101 series that we launched a year ago, or almost a year and a half ago, it was more geared towards fiber theory, understanding about fiber connectors, and what's the difference with the different fiber cables, whether it's single mode or multi-mode. So it covered a lot of ground, and Fiber 201 did the same thing. So if you were able to join us for this complete series, we talked about fiber math, fiber test equipment, restoration, and fiber documentation, and that all kind of led to this fiber to the home troubleshooting, this final module. So when we do the Fiber 301, it would be more streamlined, where we would probably focus more on like for example, like an OTDR. It would be less about how to set it up, but more about how to interpret your traces and the other readings that come with using an OTDR, and what those traces actually mean to you, and so to be more streamlined. But keep on the lookout on LinkedIn for future announcement about a Fiber 301 series. And then Dwayne, are you finding that techs are not issued proper fiber cleaning tool, which is causing most issues in the field? Great question, Dwayne. So I'll just answer this just from my perspective. I'm sure that a lot of people that may travel around to different cable companies and MSOs, and especially if you're a vendor and you're selling certain types of test equipment or cleaning equipment. Just like with anything, companies do a great job of issuing the right equipment and materials for the technicians. Sometimes as technicians, and I'm sure I've done this in the past myself, you would lose some tools or equipment, and instead of letting your supervisors know, you may purchase some stuff yourself that may not be the same equipment or whatever. But nonetheless, you bring up an important point, which is, especially when it comes to cleaning, is that dirty fiber connectors and patch panels and adapters account for the biggest portion of fiber troubleshooting or problems in a fiber network. And kind of going back to your point with the proper tools, even like with cleaning, as you may be aware, there's different ways that you can clean fiber, whether it's with dry cleaning or wet cleaning, but it just depends on what you think the problem might be. So if there's like moistures or fingerprints that may be on that connector, wet cleaning may be appropriate for that. Dry cleaning, when you're thinking that it's just, it could be probably normal dust or dirt that may be on it. Obviously you would always scope it first and just to kind of get a sense of what you might be dealing with. But nonetheless, you want to make sure that you are leveraging the proper equipment when it comes to cleaning fibers. And then make sure you're cleaning, the interfaces for any adapters and I can't think of. I'm losing thought about the name of what I want to say, but patch panels and using your one-click or whatever you're issued. Hopefully, though, techs are issued the proper equipment. Hopefully, they are using the ones that are issued by their company. Myself, I haven't seen that out in the field. I assume that it has happened where tech may not have the appropriate equipment when it comes to cleaning, but hopefully that's not the case. So, but yeah, great question. I'm glad you brought it up because I did want to before I wrapped up mention that going back to an earlier question from Victor. About the hardest part of like grasping, understanding troubleshooting fiber. Probably the other thing is that even though in training and other senior technicians that I would ride with, they always preached cleanliness when it comes to fiber. And, at first, I just thought it was, just something that they said, but it's amazing that how just a little dust or moisture from your your finger can affect the power levels when it comes to a fiber network. So, and that looks like that's all the questions. So before I wrap up, though, I want to thank everyone that joined the training today. And then also, if you attended any of the previous training for our Fiber 201, we definitely appreciate it. We know that you could be anywhere else during this time, so we appreciate your jumping on and talking about fiber with us today. Although you may not have caught all the other series in this Fiber 201 training series or the additional training modules, they will be available on our YouTube channel at Amphenol Broadband Solutions. So be sure to check that out. Also, if you go to training.amphenolbroadband.com, you'll find more resources. So we not just cover like fiber, we do coax and RF and a slate of other training topics. So again, appreciate your time today. Be on the lookout for new training that will be coming available. Hopefully the 301 series will be underway pretty soon. And again, have a great day and enjoy your weekend, and we'll see you next time.